guys, welcome to my channel. Today we are going to start by looking at the theoretical aspect of the number one question on our NECO practical, and that is on mechanism. Now this concept of mechanism that we are about talking about has to do with pulley, and we are to use the arrangement of the pulley to explain the concept of parallelogram law of vector and triangular law of vector. And when you talk about these two vectors, that is these two theorems, the parallelogram law and the triangular law, we use them in calculating the concurrent forces. That is, when a body is at equilibrium but is not under the action of two parallel or more forces, that is, the line of action coincides at a point. We are talking about concurrent forces in general. So to cut the story short, so we want to use this experiment to prove the parallelogram law and the triangular law. Now you need to understand the concept of this theoretical part very well before we can now say we want to look at the practical concept of it. Otherwise, the confidence will not be instilled in us. I'm going to be making this lecture to be in three phases. Phase 1 will be the concept of explanation on how your result will look like and how to determine your result. And the second phase is going to be the simulation that I brought before you from physics lab, and you see how to use this to prove parallelogram law of vector after I've explained how you can go about your result. And the third part is going to be the NECO question that we are going to be instructing, and we are going to explain how the question will goes. Now let's quickly look into that. When you talk about experiments on concurrent forces, we are going to start by looking at how to set up the apparatus. Now here I have a force board. This rectangular box outside here is the force board, and what I have inside it is a paper, a plain sheet paper, like your A4 paper or drawing paper. I'm going to attach this paper to the force board. I haven't done that. The next thing is to attach my pulley to the force board. So here is my pulley. I have two fixed pulley. They are frictionless. After you have done that, the next thing is to pass your twine. You can use twine, or you use shoemaker rope, or you use whatever rope that you know is not going to cut when you apply when you apply mass on it. So you suspend the rope around the pulley like this. Now here are mass angle on both sides of the rope. The mass here is equivalent to the mass here, and that's why you see the body at equilibrium. Now I haven't done that. We are going to suspend a mass at the center. When you suspend the mass at a center, you have the rope directions to look in this manner. Now you need to understand something. The direction of this arrow is as a result of the force P or mass P that is acting in this direction. This mass P is what caused this one to face this direction, and the mass Q is what caused this rope to face this direction. That is, and that of R is what causes to face this direction. Remember, a vector quantity is a quantity that has both magnitude and direction. So you must not make a mistake by the way you are going to represent your direction. So this will cause this rope to move in this direction, and this will cause this rope to move in this direction, while this will cause the rope to move in this direction. Now, we want to prove the parallelogram law and the triangular law. But before we go into that, I would like us to know what we call the parallelogram law of vector. Now, what does the parallelogram law of vector state? The law states that given two forces P and Q that are moving simultaneously, the two forces can both be represented in both magnitude and direction by the adjacent sides of the parallelogram, and their resultant can both be represented in magnitude and direction by the diagonal line of the parallelogram drawn from a point. Now, this side that I labeled to be P and this side that I labeled to be Q, they are the adjacent side of a parallelogram. And this line that cuts the parallelogram into what? A two triangle is what we refer to as the diagonal. So this is representing what? The resultant, and these are the two forces that will represent them in magnitude and direction by the adjacent side of the parallelogram. Now we have from the result that r square is equals to p square plus q square plus 2pq cos theta. Already this is what? This is going to be a cosine rule. But cosine rule states that what? R square is equals to p square plus q square minus 2pq cos of 180 minus theta. And you understand that cos of 180 minus theta is in the second quadrant. Hence, cos 180 minus theta is equivalent to minus cos theta. Putting minus cos theta in place of what? Cos 180 minus theta, this negative will multiply this negative, then it becomes positive, and that's why we have what? The general form of the equation here. Now, how can we then prove this with the first board that we have, that is with this arrangement? How can we prove this parallelogram law of vector? It's very simple to do. Now, let's take for instance that this is the paper that we insert under this under the pulley. Now, the first thing we are going to do is that, let's say force P is 10 gram and force R is also 10 gram and force Q is also what? 10 gram. That is, they are of equal mass. Let's start from there first. Now, this body is at equilibrium now because these three masses, they are no longer moving. Now, the shadow of this rope is set to cast on this paper. Now, take a dot like this. You take another dot like this. You take another dot like this. Then you take another dot like this. Now, let's say the dots that you take are what you are seeing on this paper now. These are the dots that you took. Have you seen it now? That is this dot, this dot, this dot, and this. This is what appear on your paper. So you have to detach the paper from the board. When you finish detaching the paper, then you connect the lines like this. So you connect the line like this. Then you connect this also like this. So if we look at this now, we see that this direction is representing what? P, and this one is representing Q, and this one is representing R, like this. Now, before we go on, we then need to choose what? A scale. Now, the scale is what we want to use to represent the forces. I'll say I want 1 centimeter to represent 5 gram. Now, if 1 centimeter is equivalent to 5 gram, it means 2 centimeter will be equivalent to 10 gram. So for every 10 gram mass, it shows that I'm going to have a length of 2 centimeter here. Now, on this plain sheet of paper now, I will then what? Let's say this is point O, because that is the point at which they all at. Are you getting it now? So I'm going to mark what? 2 centimeter like this. And I will also mark what? 2 centimeter like this. Now, this 2 centimeter here, and this is another 2 centimeter here. If I call this one B and I call this one what? A. Remember, this one is what? 0. Now, I'll pick my compass, because when you talk about parallelogram, the opposite sides of the parallelogram are always equal. Now, in order for this parallelogram law to be proved, we are going to have that OC must equals to what? OD. And the angle between what? C and D, that is angle COD, must equal to 180 degree. That is the condition for the parallelogram law to be proved. Now, I'm going to mark what? 2 centimeter like this. If I take 2 centimeter like this, I'm going to place it on B. Since I know that from 0 to this point is what? Is 2 centimeters. So I make an arc. So I'm going to make another arc here like this. So are we together now? Now, if this should be the case, I'm going to connect this point from here to this place. If I connect this like this, I will also connect this and this together like this. Now I'll call this point C, while I'll call this point here, from here to this place, let's call this one point D. Here is OD and here is what? OC. So OD must equal to what? OC. Remember, this diagram is not to scale because all these dots, they are not what? They are not what we get by default. We just use this to explain. Otherwise, if I take the measurement from C to this point and I take the measurement from here to this place, it has to be the same thing. Are we together? Now, we are going to assume now that this from C to O is equivalent to what? O to D. Now, let's check, this is a straight line now. The angle between what? That is angle O, which is angle COD, must be 180. And you can see that this is what? This is angle 180 degree. Hence, the parallelogram law has been proved. Now, what if it is now the triangular law that we are expected to prove? Now, let's look at what the triangular law states. The triangular law of forces states that if two forces acting at a point are represented the magnitude and direction by the two adjacent sides of a triangle taken in order, then the closing side of the triangle taken in the reverse order represent the resultant of the forces in magnitude and direction. This is what the triangular law of forces states. Hence, if that should be the case, the capital P divided by the small p must equals to capital Q divided by the what? Small q, and it must also equals to capital R divided by the small r. That is, if R represents what? A force, then the ratio of that force to that of the scale, if R now is let's say 10 gram, is equivalent to 2 centimeter, like we have chosen our scale. Now, if I take the ratio of 10 to 2, now this particular one here, let's take for instance that Q is 20 gram. If Q is 20 gram, then I'm going to have it to be what? 4 centimeter. So I have to put 20 divided by 4 here. So you can see that this and this, they are both equal. So the same thing must go to the third one. The third one also can be, let's say if it is 30 gram. So if it is 30 gram is going to be what? How many centimeter is going to be? That's going to give us 6 centimeter. So if I put that here, this is 10 divided by 2, 20 divided by 4, and this is 30 divided by 6. You will see that they are all what? They are all equal. If these three are not equal, then the triangular law is not verified. Now, how can we use the first board to verify that? It's the same way that we did for that of the parallelogram. We pick the points, so we have something like this diagram like this. So the next thing we just need to do, we can prove that in two ways. We have what? The set square method, and we have the other method which I call the most easier method, which is going to be the one I will be using here. And if you're interested in knowing the set square method, you can let me know. I'm going to make video on that as well. Now I'll place my ruler here to extend this line down like this. If I do that, I'm going to extend this one also like this. Now, this particular line now, I have to create a line that will be parallel to this. So, if I create the line that will be parallel to that, I will have something like this. Now, if you look at this now, this shape here is now a triangle. Now, this is vector R is facing downward, so the direction has to be facing downward like this. And if you look at it, this is vector what? P. In the other way around, this is also P, so this one will also be facing this direction. And this is what? Q, which is also facing this direction. Now, what I'm going to do next is that I'm going to take what? The measurement of this. So when I take this is 2.5, which is small p. Small p is 2.5 centimeter. And this is what? Small q. Small q is also what? 2.5 centimeter. And here is our small r, which is equivalent to This is 3.38, so this is 3.8 rather. Okay, this is 3.8 centimeters. So this is what a triangular law of what? Triangular law of forces or triangular law of vector. So if this will be true or correct, so I have to say P divided by small p must equal to Q divided by small q and must also equals to R divided by what? Small r. Once this is correct, then your triangular law is also correct. Now, this is just how to prove the parallelogram law or the triangular law using what? These concurrent forces. Now look at something. Now we can also use it to determine the value of unknown. Let's take for instance that our R is not known. I'm going to what? Reproject what? This point again for clarity's sake. Now if I have this like this, let's say I have those dots like this. Remember, the dots are not accurate, but when you are carrying out the experiment, you are going to have what? Accurate points taken. So if I have this diagram like this, now let's take for instance that I know force P and my force P is given to be, let's say, 20 gram, and I know my force Q to be, let's say, 30 gram. You know, at this point now they are not of the same value. So we have what? P to be 20 gram, we have our Q to be 30 gram in this case now. Then we don't know the value for R. Now, if we don't know the value for R, how can we determine the value of R? We go through the same procedure. Remember, if we are using what? A scale of 1 centimeter equal 5 gram, then we are going to have that P, which is what? 20 gram, is going to be the same thing as 4 centimeters. So I'm going to measure 4 centimeter here. So if I measure 4 centimeter here, and I will then measure what? This one is 30. So 30 gram is going to be equivalent to 3 centimeters. So I'll mark 3 centimeter here like this. So if I mark 3 centimeter here, all I will do next is that I'm going to what? In most cases, these two forces are always of the same value. But should in case they are not of the same value, you don't have any reason to panic or to scare that you're not going to have your accurate answer. All you just need to do now is to what? Is to take this, which is what? 4 centimeter, then you make an arc. So when you make your arc like this, so you mark this now, which is 3 centimeter like this. So then you come here, you make your arc like this. Have you seen it now? So this arc that you make now, we connect this to this like this. So when we connect this to this, we also connect this to this. So we connect this to this. So for us now to get the value of what? The value of R, we just have to take the measurement from this point down here. So if I take the measurement from this point down here, let's take for instance that I have 4.5. If I have 4.5 centimeters, so I'm just going to check that if 1 centimeter is equivalent to 5 gram, then 4.5 centimeter is going to be what? So I will have that X is 4.5 times what? Times 5. So 4.5 times 5 should give us what? That should give us 22.5. So 22.5 gram is going to be the value for R, which is the unknown mass. So that is how to go about what? About the experiment. If this diagram is perfect, you are going to have this particular angle here to be what? 180 degree, because it's said to form what? A straight line. Are we together? So let's quickly look at the short simulation from physics lab. Why we look into that? Once we're done looking at that, we are then going to consider the NECO question. The NECO question is just based on the triangular law, and I will be explaining how you can go about it. Then after looking into that, then we now look at the experiments together, and we'll talk about the manipulating skill in it. So let's quickly go into what? The physics lab now and see what is happening there.
Parallelogram law of forces. Aim: verify parallelogram law of forces. Apparatus: drawing board with 2 fixed pulleys, 3 sets of hanger weights, twine thread, protractor, set squares and drawing pins. Parallelogram law: If two forces acting at a B presented in magnitude and direction by the two adjacent sides of a parallelogram drawn from a point, the resultant is represented in a magnitude and direction by the diagonal of the parallelogram drawn from the same point. Theory. Let OP, OQ and OR be the three coplanar forces acting at a point O. A triangle ABC is formed by drawing parallel lines to OP, OQ. The sides small p, q and r of the triangle ABC represents the forces OP, OQ and OR. Then, according to the parallelogram law of forces, capital P by small p is equal to capital Q by small q is equal to capital R by small r. Fix a white paper to the drawing board. Fix two pulleys to the drawing board. Place the strings such that they pass through the pulleys. Take a set of weight and hangers, water in a beaker, a stone whose volume has to be found. Add the weight hangers by holding the strings such that the arrangement is not disturbed. Release the string. Wait till the arrangement comes to rest. Turn on the light. You can observe the shadow of the string on the white sheet. Mark the point O with the pencil at the center where the knot is present. Trace the points R, P and Q carefully in the direction of the forces R, P and Q. Remove the pulleys. Join the points O and R to form a line OR. Join the points O and P to form a line OP. Verification of parallelogram law of forces. Use the scale 50 grams is equal to 1 centimeter. Mark the point A on line OP such that OA into scale gives the weight suspended at P. Mark the point B on line OQ such that OB into scale gives the weight suspended at Q. Mark the point D on line OR such that OD into scale gives the weight suspended at R. Take a compass to mark the resultant force OC from the forces OA and OB. With point B as center and length OA as radius, mark an arc with compass. The intersecting point of both the arcs is point C. Join the point O and C, A and C, B and C. Resultant parallelogram is formed. Measure the angle COD and note it in the tabular form. Measure the length OC and note it in the tabular form. If OC is equal to OD and angle COD is equal to 180 degrees, then parallelogram law of forces is verified. Precautions. 1. The pulley should be frictionless. 2. The weights should not touch the drawing board. 3. The drawing board should be perfectly vertical. 4. While marking the shadows of thread, the weights should not oscillate. 5. The hangers should not touch the board.
So, haven't seen the experiments on how to arrange and carry your experiments out on parallelogram law of forces. Now, let's quickly look at the question that we are expecting from NECO. Now, here is it now. If you look at this question, from the diagram, this is how your apparatus will look like when you finish setting it. You know, the other example that we see from the physics lab is that what? We have what? 3 forces. But in this case, we have just 2 forces. And absolutely, you can see that we are actually dealing with what? A right angle triangle in all cases. So, that's good. Mind you, this is an unknown mass W. And the value for this W is going to be what? 30 grams. Nobody will tell you that because that is what the experiment is about looking at. But you just know that it is 30 grams, so that when we are explaining a way of manipulating it, you are going to understand and carry out your experiment out with confidence and what high level of accuracy. Now, this is mass M. As always, let's take a look at the diagram, at the question. It says in the diagram, a thread AC, this is thread AC, fixed at pulley A, pass over pulley C. So we fix this, that is, you are going to tie it, fix permanently. It's not going to move on A. You are going to tie it to what? To pulley A. Then you are going to suspend it on what? Pulley C. Mind you, and note that on a force board and carries an unknown mass W. This is an unknown mass W that we attach to the end of what? The rope. Okay? If that should be the case, retain the mass W throughout the experiment. That is, we are going to let this mass remain here throughout the experiment. Draw a line along the direction of AC. So we are going to what? Draw a line. If you are going to draw this line, you know, the white paper is already on the first board. So you just take a dot here, you take a dot here, and you rule a straight line. That is how you can draw the line along what? Along AC. Now, what else they ask us to do? Okay, we have already explained that. Locate the midpoint B. So after you draw the line, you find the midpoint of the line to be B and mark its position on the line. So we are going to what? We are going to mark the position of B on that line. Okay, draw BP. So this is a straight line down here. So that is what we call BP. It should be a straight line. So at right angle to AC. So it means you can say this is at right angle to what? To AC. We are already told what to do here, so you have to carry out whatever the instruction likes, and you see that your results will end out being what? Being an accurate result. By means of loop, so it means we are going to have an external thread that we are going to what? We are going to create a loop on it and attach it to what? AC, as it was explained in this what? In this question. So on the loop, we suspend a mass of 5 grams from what? AC. So by the time you put the mass 5 grams, it's going to cause the what? The rope to come in this manner. Okay? If that should be the case, what else they ask us to do? Adjust the position of the loop so that the line of action of the weight of M lies along BP. So we're going to adjust what? We're going to adjust the loop such that it's going to be in the same straight line as what? As line BP. We have to be careful in doing that as well. So ensure that M and W hang off the board. That is, you make sure that M and W, they get to a point of rest. That is, they are not shaking, they are not moving. They have to be at equilibrium. That is, they come to rest before you do any other thing on it. So measure BO. You have to measure the distance from B to point O. Then let that equals to Y, and AO. So we are going to measure the distance AO like this. Okay? Evaluate what? Y over AO. Repeat the experiment for mass equals to so. Are we there now? Now, let me quickly explain something here that you need to understand. How do you make your measurement for AO, and how do you make your measurement for BO? It's very simple, and that is what we explained in the beginning of this video. All you just need to do is to take a dot here, and take a dot here, and take a dot here. So when you do that, you connect those dots, then you remove the paper. So you take your measurement and you record it. Then you put in another what? New paper when you're about slotting in another what? New mass. And that is how we're going to go about this experiment. I believe you already have what? Idea on what is expected of you now. Now that you have idea on what is expected of you during the exam, by His grace, because of the protest that is going on currently in Nigeria now, I'm having issue on going out. So I could not reach the lab in order to carry out all this experiment. But I promise that a day or 2 days before the exam, we are going to have this exact question. We are going to carry it out as if we are in the exam hall, and we are going to what? Explain the do and don'ts of this particular question, so that we can all what? Pass and what? Have what? Accurate result in this particular exam. Actually, physics questions are being practical. They always come in a very simple manner, such that once you can read and write, you can carry it out. But the essence of all these things that we are preparing for is to instill confidence in us, and so that we can caution ourselves if we are doing the right thing or the wrong thing. That's the essence of all this. Please guys, bear with me. You know, when you are live, that is when you can make what? A video. And also it is when you are live that you can learn. So please, let's stay safe. And currently now, like 3 days now, I've not been out, I've been at home. So please guys, let's stay safe. And by His grace, 2 days or 3 days to the exam. I was told now that the exam has been suspended in Lagos and also in Oyo State. So I believe all over the states they suspend the exam currently. So by the time they resume back, 2 days before the physics practical, you are going to see what? The complete lecture. All apparatus, we have already got them. Everything is set. And kindly share within your friends, and stay tuned as we drop the video as soon as possible. Guys, stay safe, and thank you for subscribing to this channel. If you are yet to subscribe, kindly do. You are the reason why I'm making this video. And thank you always. As always, we are still a friend.